All right. Example 5. We're expanding this out again. But what is different about this problem compared to the other problems we've done? And hopefully everybody's noticed that the difference is this part right here. So instead of us actually doing addition signs, we're going to do subtraction signs. And for some reason, I'd say this every time, and people still like throw negatives all over the place, and just because it's got to be there, do not touch the negative until the very end. We're going to do everything the way we've been doing it. The only time we use that negative is at the very end. So don't take the negative with the y. Don't take the negative through the problem at all, because it's so much work that you're going to get it wrong. And I don't want you to get it wrong. All I want you to do is just do what we've been doing and then add the negative at the end. It's going to be simple and easy. Just do it. Just stay with me. All right, so we're going to expand this just like normal. But this time, because it's subtraction, the very end is going to be a little different. That's it. So let's take a look at the problem here. Oh, you don't see that part yet. That was the change, that last part at the bottom. But we're not going to do that. I'm not going to let you see that part yet. So we're going to expand 3x minus 1 to the third power. All right, again, using our coefficients, and because the numbers aren't huge here, this should be very quick and easy. So we start with 3, 0, 3, 1, 3, 2, and 3, 3. Okay, again, in the calculator, when you put it in, we know the first one and the last one are 1s. We know this one is 3. And actually, you're going to realize, okay, this actually just 3 also, because it doesn't double back on itself. There's nothing else that can make it double back on itself. So it's 1, 3, 3, 1. And you didn't even have to do Pascal's triangle. You didn't have to do any work on that. Okay. So here we do our first term, just like normal. We haven't changed anything. Okay. And here we go ahead and add in the 3, 2, 1, 0. And with our y's, again, we just add the y, leave the negative alone for now. That's at the very end. So we put the y in there, leave the negative alone. And again, we start off with 0 and we go all the way to the highest exponent, which is 3 here. Okay, get rid of anything to 0 power. Get rid of it, you don't need it. All right, and again, make sure when you do these parts, you raise both of them to the third power here. So that's 3 cubed x cubed. So that's 27x cubed. For the next one, 3x squared. So the 3 gets squared and the x gets squared. So 9x squared. Then for the last one, that's 3x because it's to the first power. So when we rewrite this part, we have 1 times, instead of writing 3x to the third power, we write 27x cubed. Put 3, and instead of writing 3x squared, quantity squared, we say 9x squared. Here we just do 3x, because to the first power is just 3x. And then here we put 1. And again, add your y's in. You can okay. And then the last thing is to simplify everything down. So 1 times 27 is just 27x cubed. 3 times 9 is 27 x squared y. 3 times 3 is 9x y squared. And then the bottom one is just y cubed. Okay, now the subtraction part comes in right here. And all we're dealing with is, instead of actually doing addition signs for each one of them, we're going to do something else. So I'm going to write all these down, these what we have here. Leave a space between them. So again, leave a space between each one of those pieces, and I ran out of space on the side here, so I went on to put the y cube down here at the bottom. And also, I'm going to box this off too, because that has nothing to do with the answer. Nothing to do with the answer. That's to help us get to the answer. Now, looking at this part, and this is the part that was covered up. When it comes to our subtraction, what we're going to do is alternate signs, starting with a positive sign. So we're going to alternate signs. So that means it's going to start off positive, then go to negative, then positive, then negative, positive, negative, till we get to the last number. So it's understood a positive here, then negative, then positive, then negative. So positive, negative, positive, negative. Oh, you can't see it. Sorry. So it started off positive here. So you can see it bigger. Start off positive here, then negative, then positive, then negative. So alternate signs until you get to the end. But it always starts with a positive. So to finish it up, we normally don't put a addition sign or a plus sign at the beginning of this whole thing, this binomial. So we're going to take that positive off the front, because we don't normally have a positive in the front. But we say positive because that helps us keep everything together when it comes to alternating signs. And this is our final answer. And that's it. That's it, guys. That's all.